Before actually getting our hands dirty with Terraform code and all the complexity of it, we need to understand why do we actually need Terraform. And before that, we need to understand what exactly is Terraform, how does it work, and what is infrastructure as a code. So in this video, we'll be covering all those aspects, and all these are really important concepts to understand why are we using something, right? So otherwise, the next 30 video will be of no use if you don't understand why are we even using it. You might be already familiar with the concept, you might be already aware of all these things. If that is the case, you can skip this video and move on to the next one. If not, let's go ahead with this video. Before that, I just wanted to mention that 70% of the viewers just watch the video and don't subscribe the channel. So if you are one of those 75%, please, I request you to subscribe the channel. It really makes a lot of difference. It helps us to promote more such amazing content in a very high speed without compromising with the quality, but we need your support in doing that. So I'm sure you will do it. So let's start with our video. We need to understand what exactly is infra as a code in the beginning. Okay. So what is infra as a code or infrastructure as a code? Meaning translating our infrastructure in a code. In simple language, you write the code for your infrastructure, right? Such as, from servers import EC2 or something like any programming language, any shell script or anything in commands or any format. You just write the code to provision your infrastructure. Like this infrastructure could be servers, this infrastructure could be multiple other resources in cloud, such as we are talking about AWS, so virtual machines, AWS VPC, S3, firewall rules, EBS, IAM, and a lot more resources. So with this particular approach, when we write the code to provision the infrastructure, this is called infrastructure as a code in the simple language. Now, there are different tools for infrastructure as a code, such as Terraform, which is why we are doing this series. Terraform is the universal and most popular tool out of all of those tools. Pulumi is also one of the universal tools. Universal as in it works with most of the cloud providers. And then we have some cloud native infrastructure as a code, or the vendor lock-in tools, such as Azure ARM, which is Azure Resource Manager Template, and Bicep. These are Azure specific. Then we have AWS CloudFormation, AWS CDK, AWS SAM. These all are AWS specific. Then we have GCP specific IaaS tools such as Deployment Manager, Config Controller, or Config Connector. So you don't need to learn all the tools. You don't need to understand all the tools. So you need to just start with something that is most popular and that works with most of the cloud providers. So that is why we have chosen Terraform to do that. Now we need to also understand why do we actually need to do that? Why do we need to write the code when we can just log into the console? So each of the cloud provider has their own console, like we have AWS console, Azure portal, and GCP cloud console, right? If all of these cloud providers are providing you a nice GUI to interact with their services, with their APIs for resource provisioning, why do we actually need to write the code for that? Like, why are we creating our life difficult with that? I'll explain it to you in a bit, but let's understand it a bit more. We need to understand the problem in a bit more. Okay, let's take this sample 3-tier architecture. Okay, what a 3-tier architecture is, it's basically have multiple tiers, like a web tier for the public facing applications, an app tier for hosting your backend, and then a database tier for your database, right? So just don't understand it from the AWS perspective for now. Just try to think about from an app hosting perspective. It could be any cloud and it could be on premises as well. The concept remains the same. It's a 3-tier architecture that we are discussing. So we have multiple resources over here, right? So you need to create multiple servers, like multiple EC2 instances, auto scaling groups, multiple load balancer, one external facing, one internal facing load balancer. Then you will have maybe CDN, Route 53, health props, and then you have databases, master, and slave replica, and so on, right? So there are so many resources that we are provisioning, VPC as well. Now, if you do all that manually from the cloud console, it could take roughly 2 hours, let's say, because database also takes time to provision and you have to do each of these step one by one. So 2 hours, not a big deal, right? You have spent 2 hours to provision an infrastructure, but this is just for one single app, and this is just for a simple 3-tier architecture app. It doesn't have any complexity. It is not reflecting the actual application that an enterprise has. So if we go ahead and check this, because earlier you see just one environment for one application, now when you move into an enterprise, you would have multiple environments for different use cases. Like you have a dev environment, a system integration test environment, performance testing environment, a disaster recovery environment, a prod environment, and a pre-prod or staging environment, right? So now the complexity increases. Now instead of having a single environment, now you have 6 environment per application. So the time that it will take now is 12 hours per application. Still not really bad, right? But an organization, an enterprise level company don't just run on a single application. They run on multiple hundreds and thousands of applications. Now just calculate the time. Okay, things are getting scary, right? You cannot do all of these things manually. It becomes cumbersome, it becomes almost impossible, and then there will be no point of using the cloud, right? If you are doing all of these efforts, if you are putting all of these efforts, there is no point of using the cloud. Now, what all challenges that it comes with? So first is, let's say your infra team is spending 12 hours per day per app to provision an infrastructure, and your dev team and rest of the teams, like your performance testing team, your QA team, and rest of the teams are dependent on your infra team. So they cannot start working without infra team provisioning the environment, right? So there is a dependency between them, and most of the time they will sit idle. Now the other issues that we have, yes, time is an important issue. So this is too much, and this is just for one app. There could be hundreds of apps, so calculate the time. Now there are a lot of people that you need to provision the infrastructure on a daily basis, and those people will just be provisioning the infrastructure. It's not really an efficient use of resources, right? And because you need more people for infrastructure management, that means you have to spend a lot of cost for that, and it becomes a repetitive task. The same team, let's say a team of 50 people, just go to work and provision the infrastructure. At the end of the day, they destroy the infrastructure to save the cost. I mean, that's not really a good use case of putting your infra team to use, right? And because they are all doing it manually, that means there could be human errors. So instead of adding some database host that the application expect, they could add something else, and your application could go down, or it could take some time to troubleshoot and mitigate the issue. So those issues could be there as well. Then it will become insecure because you are doing everything manually, right? There is a chance that you miss something, you miss enabling encryption, or you miss something that could exploit the application to outside world or to any intruder. And then the classic problems of it works on my machine, because now let's say you are provisioning 6 different environment per application, and you are doing manually, and maybe the person that is doing the first environment is not doing the second one. There's a different person who is doing the other environment. So there is a high chance that these applications, these environment, this infrastructure is not consistent. So your dev and prod might have different setup or different configuration, different dependencies or libraries installation, right? So there could be some code that will work on your local machine or your dev machine, and it doesn't work on prod, right? So it arises with this problem, it works on my machine, right? So you see, there are numerous challenges that we had with the traditional approach, especially when working with the cloud, right? So what is the solution for that? So tools like Terraform is why we use it. So what it does, it instead of going and manually provisioning the infrastructure, what we do is your DevOps team, I'll just write it down over here. Let's say your DevOps team or your cloud engineering team or your infrastructure team, whatever team is responsible for doing it, they will just write the Terraform configuration once, and then they just use it to provision the infrastructure, which will save your resources. Resources as in your cost, your people, your financial resources, time saving. It will save a lot of things, all the challenges that we discussed earlier. Then it will help with the maintenance. That means all the updates, any security patches, any updates can be done with the help of the same configurations. And then at the end of the day, or when you don't need the environment, specifically the non-prod environments like dev, testing, performance test, if you don't need that to run 24 by 7, you can destroy those environments to save the cost. And that also can be done easily with Terraform, right? So it will help you with save time, consistent environment, because now you are using the same script, same file to provision multiple environments. You can create hundreds and thousands of environments, and all of these environments will be consistent when it comes to their infrastructure, right? So it works on dry principle. That means write once, deploy many. Actually, dry is don't repeat yourself. So that is also a feature with the custom modules. We'll see that later on, or with the modules as well. But for now, write once and deploy many. That means you just have to write it once, make some changes if needed, and then you can use that to deploy it hundreds and thousands of times. There is no limit to it. And then you can also track your changes to version control. Now, with the manual approach, you wouldn't know what mistake someone made and when it was actually made, right? Someone can go to your environment and make your changes if that person has the permission. But with this, now everything is committed to GitHub or a version control system. So you would know when the changes was made, when the infrastructure got changed or destroyed or provisioned. Everything is tracked over there. So there is no blame game whatsoever. And life's become easy for everyone, for infrastructure team, for DevOps team, for developers. Everyone is happy because now they can focus on what truly matters. Now they can focus on building their app and working on other things, CI/CD pipeline, and working on everything except their infrastructure creation and destruction, because that is automated now. Okay. So let's understand how does it work on a high level. We'll get to know in a much better way when we actually do it. But just to give you a gist of it, just to tell you what's coming up next, I'm just gonna spend a few minutes on this. And I promise when we do the hands-on, when we do everything end to end, you should be able to create any infrastructure in AWS using Terraform. So let's understand this. How does it work? So you have a DevOps engineer or a DevOps engineering team who is responsible for writing TF files, right? So what is this TF file? This TF file is, so the extension is .tf, right? And it's a HCL language. HCL is HashiCorp configuration language. So for Terraform specifically, HashiCorp created a configuration language. It's similar to JSON, but it has its own structure. It is human readable as well as machine readable, right? Using this language, and don't worry, don't get scared about like it being a programming language, because it is not. It is so simple and easy to use. It is just like JSON. Like how do we use JSON? It is as simple as that. So this language and all the files are written in .tf extension, so that Terraform detects that it's a Terraform file. So you write the file as a DevOps engineer, check into GitHub or the version control system that you are using. Now using GitHub or using the files that you have written, either you can run these commands manually. Okay. What are these commands? Terraform init to initialize the infrastructure. This is done for the first time. Terraform validate to check if there is any syntax issues or any validation linting errors or so. Terraform plan to plan the changes. Like when you run Terraform plan, it will dry run your Terraform command. It will show you, okay, so after you run the apply, these are all the changes that it's gonna do. Maybe 10 resources will be created or 4 resources will be deleted. So it will give you a dry run plan for this. And once you run Terraform apply, then it will actually apply the changes. Then it will actually create the environment, create the resources for you. And how does it do that? It actually interacts with, so there is one point missing over here. It actually, to provision the infra or to modify the infra, it actually calls AWS APIs. Okay. So using the API call, like when you create a resource from AWS console, it actually contacts the API. When you do that with AWS CLI, it also interact with the API, and this is what Terraform also do. It calls the AWS API to perform the action. It could be creation of resources, modification, or deletion, right? And this Terraform, it does with Terraform provider. Okay, I'm not getting into provider right now. It's the topic for the next video. So let's just understand this. Okay, so just a quick recap. A DevOps engineer write .tf files, which is in HCL language, and then they store it in GitHub or version control system. Then using CLI, they can run these Terraform commands to make the changes, or you could also have a CI/CD pipeline like GitHub Actions to provision the infrastructure whenever there is a change in the GitHub repository, right? So it will auto detect the changes and it will apply the changes to the infrastructure. Now, using the Terraform destroy command, you can delete the infrastructure as well. So Terraform will check, okay, so these are all the files that we have, and it will delete all the resources mentioned in the TF file if you have not specified which resource to be destroyed, right? So we'll see all of that in action, but just wanted to give you a overview of it, like how does it work. Okay, so if we go back to the GitHub repo, I'm sure you might have already seen it. If you have not checked out the day 0 video, please go ahead and check it out, because it will have a lot of important details about this series and 30 days of AWS Terraform challenge, the prizes, and like the submission details and how do you participate in that. And you can go ahead now in this AWS repo. I will share the link in the description of every video. If you ever stuck, ever face any issue, join this Discord community, and here are all the socials. Make sure you subscribe the YouTube channel, right? And here are some prerequisites like AWS fundamentals. You should have a Visual Studio Code setup, Git install. You should have the basic knowledge of Linux, shell scripting, YAML, JSON, and some fundamentals, right? So nothing fancy, nothing advanced, just some fundamentals knowledge. Now, in this video, we have covered all of these things. Now we'll go ahead and start with Terraform installation and get ready for the next video, because from the next video, we'll be doing a lot of hands-on. I mean, all of the videos after this will be complete hands-on. Okay, so let's go ahead. I'm in my Visual Studio Code. So there is a dedicated folder that I've created. Now you can follow this link to, let's open this link, and this link will have the installation instructions. So there is installation command for Mac OS, Windows, Linux, and so on. So whichever operating system you are using, you can check it out. It's pretty straightforward, pretty simple. Like for Linux, you can just use the package manager and run these commands. For CentOS, RHEL, similarly, you can run yum package manager and execute it. For Mac, you can use Homebrew, which is what I'm going to use. So brew tap HashiCorp tap, and then brew install HashiCorp tap HashiCorp. So that's what I'm going to use, and this is same over here as well. So let me just copy it, and I'm going to paste it over here. Okay, so brew is a package manager for Mac OS. Yeah, in case you don't know that, but yeah, it says. Okay, I think it should have been installed. Now let's just run Terraform version. Okay, so it says version 1.13.3 has been installed. Now we'll do some setup. Let's set an alias so that it will be easy to run Terraform commands. So tf equal to Terraform, right? So now if I run any command like tf init, which translates to Terraform init, it will say Terraform initialize in an empty directory, because I don't have any .tf files over here, right? So we'll see that later on, but just wanted to get started with it. Now you can also do the bash completion. What it will do is it will auto complete your Terraform commands. So I'm just gonna run this Terraform -install -autocomplete. Okay, it says already installed in bash profile, so I don't have to do it. That's good. Now the next thing, in VS Code, you can install your extension for Terraform. So go ahead and search Terraform and install this extension by HashiCorp, right? So that is sufficient. That is more than enough for learning the Terraform. I believe that is it for this video. Let me quickly check if there is anything missing. we have done all of those things. Yeah, I think that is it. And in the next video, we'll be doing Terraform providers, version control, version constraint, and operators, and so all other things. Why does it matter? So make sure you complete the task. Task is also there in the day one folder of this GitHub repo that I've just shown you. Make sure you complete the task and do the submission. All the details are already there in the GitHub. Plus, I have provided in day zero repository. So I hope you are having a good learning experience, and from now on, you will be seeing one video daily. So make sure you follow this along. Make sure you complete each and every task for the better learning experience. I will see you tomorrow with the next video. Thank you so much for watching.